Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
I wasn't planning to do this video tutorial, but I thought let's just do something playful, just something silly, nothing serious. Because I think I mentioned it in this 136, that one of the options when we work in time series is to log our actual values, and that helps a lot in terms of the variance and things like that. So from a regression point of view, logging our variables are always advisable and preferable. So I thought let's just, for interest sake, generate the log of our 4 variables and then see what that looks like compared to presenting it in the actual format. So this is pretty much, as I said, just a very playful video, nothing serious, but I do think it's something to consider when we do any type of time series or spatial work, is to consider using the values in their logarithm format. As I said, from a pure statistical point of view, and a regression point of view, it's always advisable to log them because it decreases the variance. And what we want for unbiased and true estimates of our coefficients is we want a constant variance, and that's exactly what by logging we're trying to do, is to minimize the variance. So let's have a look and see how we're going to do this. So we cannot within GeoDA perform those sort of calculations. We can perform them in Excel, so we can do those sort of things in Excel. So we just go to the one that we want to transform. We basically just right click and insert to the left, insert. Okay, and basically we're not going to use the log, we're going to use lin, and we basically just select the value that we want to log, we close it, and there it is. So the lin, natural logarithm of 0.26238, is minus 134, etc., etc. So yeah, so we can do it in Excel. So that's one way of doing it, but as I said, then we have to again convert this into a shape file, and so let's rather not do it in Excel, but we can obviously check our data in Excel. The best is to go to QGIS and do it in QGIS. So then it's already done in the shape file format. So that's the least of the dramas, easy to do. So we're going to go to our shape file, and we're going to open its attribute table. There it is. Just want to make sure, yeah, I've already opened it, so I just want to close the second one. And there's our data, the ndvi mean, the ndvi, the elevation, the rain, and the temperature. And remember, this is the poly ID that we created in GeoDA to generate the weight matrices, to generate our spatial weight matrices. So that's why that is here. Okay, so what we're going to do, basically, we want to create the log values of each of these 4. So we're simply just going to go to, you can add, activate the toggle mode. You can do that. It's not necessarily. I simply go straight to my calculator. So open field calculator. So I go to that specific tab or functionality. I left click on it. And it opens my field calculator. So in this case, I'm going to say what I want to do is I want to do the lin of the ndvi. So the log of the ndvi displayed for me in decimal, because we've already said it's minus 1.234. And when we do the logs, the decimals are important simply because it decreases the variance. We can leave the output field and the precision, we can leave exactly the same. So all we do give it a name, choose a decimal number. Now what we need to do here is to find math. Okay, so we're going to go to math. We double click on left click there, always left click. And then we look for the ln. There's our ln. It says here returns the natural logarithm of a value. Okay, so there is ln to 0. It gives you, okay, so we left click on it. Now it's opened up in the expression window. Okay, so now it's expression. So now what we need to do is we want to tell him the log of what value, the log of ndvi, and it will bring it up. Click on it and close the bracket. So now we're saying generate the log of the ndvi, give the present the values in a new column, and that column must be in decimal numbers. It gives you an idea what the number will look like here at the bottom, and you simply just press OK, and voila, there it is. So let's quickly do for the rest as well. So we're going to go ln elevation. Let's do that. Remember to make it decimals. We're going to go to math. We're going to go to ln, and it's going to be elevation mean, and we close the bracket and we press OK, and there it is. So let's do the next quickly ones, quick. So we're going to go ln rain. It's going to be math. It's going to be log, and it's going to be rain. You just type it in. They will bring up the attribute or the variable name. You just click on it. Then make sure they almost forgot decimal number. Press OK. And there it is. So there's my ln ndvi, my log ndvi, my log elevation, my log rain. And now the last one that we need to do is log of the temperature. So we're going to say ln temp. We're going to go decimal number. We're going to quickly go to math, and we're going to go to log, and we're going to go temperature, just the beginning, and we're going to close the bracket, and we're going to press OK, and there it is. And we untoggle to save the data, to save the attribute table, and there it is. Ln ndv, ln elevation, ln rain, and ln log, or log temperature. So there's all the values. Okay, so nice and easy to do it in the attribute table in QGIS. We're going to close it. And then let's open. Okay, so it's saved now. So we're going to open it in GeoDA. So I'm going to go open. I'm going to click on that. Make sure. I'm going to quickly do that. Let's just open it there. And oops. Come on. As I said, this is a little cumbersome that it's two separate windows. But anyway. Okay, so there it is. Let's quickly make sure that we have the log data. And there it says log ndvi, log elevation, log rain, log temperature. So we brought it in. There's 21,155. So let's start quickly from the beginning, and let's see what visually how they compare. So let's go and generate. I like natural breaks, so let's go 8 natural breaks. We're going to go. Let's do ndvi in its standard format. So that's what that looks like. So we actually need to make a mental note of it. So have a look. That's the ndvi image of our region of interest in its actual numbers, in its true values. Now let's have a look and see if I go seamless, take it away, go again, natural 8, and we're going to go with the log one. And it looks pretty much the same. So from that point of view, there's not much difference between the two. Let's look at the other variables, seamless. So let's have a look at natural break 8, and let's go elevation, the actual numbers, and that's how it looks. Yep, okay, so make a mental note there. So we're going to go, first of all, seamless again to get rid of that. So we're going to go Natural base again, 8, and we're going to go log elevation. Ooh, this looks much better, looks much different. Yeah, so this looks actually quite neat, because you can see the rivers. This brings it out very, very nicely. You see, that's the big river there, and it connects. So these are side flows into the river. And you can see there the flows, streams from the mountainous area. So this actually looks very, very interesting. In fact, this looks much better than in the actual values. So it's actually visually much better to present it, because it presents the elevation dynamics or the detail much better than if you work with actual values. So that's actually quite neat, don't you think so? I think that's quite neat, and it presents the elevation in a very, very different light than if we just use the normal values, simply because it condenses the variance, and that's exactly what we want. We want the intrigue, the finer details to be presented. That's exactly what this does. So that's quite neat. So let's have a look and see in terms of themeless again. We go, let's have a look, natural 8 again in our rain. Oh, so that's interesting as well. And actually you can see the clustering effect. You can see the clustering effect of the rain. You can measure the area that that receives similar amounts of rain. Let me put it this way. And that's quite interesting by itself, because you can see the rain is not localized. It covers a specific area, and that area seems fairly standard. And we can actually go and measure the area, because we know what the size of each cell is, each pixel is, so we can go and measure it. But you can see the clustering nature of it. Very little rain, and as we go north, east, southeast, this area here, that the rain picks up, getting more and more and more away from, because remember, this is ocean. So this is the sandy area. This is typically your natural vegetation, the ground here. It's a pity one can't overlay. So let's see if we can't map layer settings. We can't overlay images, unfortunately, or put them next to one another, because that would have been interesting. No, you can't do this either. Okay, but anyway, that gives a nice indication of the structure, the spatial nature of rainfall and the clustering patterns in rainfall, and we can actually go and measure the size of, call it, equal amounts of rain, for lack of a better way of. So that's again quite a neat way of presenting the data and interesting dynamics that we can learn from our region of interest. It makes sense, huh? It makes a lot of sense. So let's go and look at the temperature. And I presume we should get something similar. Let's learn temperature. Oh, there it is. Oh, temperature is much more erratic, and again, this is also interesting because it shows you the changes in the temperature. That the change in temperature is fairly localized. So this is again quite interesting. You can see the low lying where it's very hot, the high areas where it's a bit colder. So you can generate some interesting temperature images here, which is also quite neat. So by using the log of our values, the visualization parameters are much better. We get much more finer detail through our visualization than if we use the actual values, and that is simply because of, again, we decrease the variance, and so therefore minute differences become much more evident, or much more visually than if we didn't do that. So I think that seems to be one major advantage of using the log. It's just visually it looks much better, the finer detail, as I said. Otherwise you would just a normal map. So benefit number one of logging is visually we see much more of the the finer details, the underlying dynamics of our region of interest. So that's quite neat. So let's quickly look in terms of just one thing that I want to illustrate is this issue of the variance. So let's quickly, for that I want to do the more on I statistic, but again we need to add our weights. So our weights are not opened yet, so we're going to go to our weight manager. We're going to load it. We're going to load the queen, and we're going to load the rook. Remember, we've generated these ones in a previous video tutorial, so I'm not going to go for all of them again, but that's the queen. Remember, the queen has much more neighbors than the rook. The rook has fewer neighbors. The rook is, you have to share a boundary. The queen is, you must just touch one another. So that's the difference between the two. So the queen, much more neighbors, 8 in this case. Rook, less neighbors, 4 in this case. The difference being the definition of what a neighbor is. Let's close that now. So we're going to go to space. We're going to do univariate. Then I'm going to go to the mean first, and I'm going to keep the queen. Eeny, meeny, miny, moe. Let's keep the queen. And we're going to run it. There it sits, 0.911. And you can see the actual values distributed between -4 and 4. So that is its distribution, again from here, -2 till about 4. Okay, so let's quickly do the same, but for the log one. The log ndvi, and click the key and press run. Come on, sorry. Why does it want to do this now? There we go. And here you can see the difference. You can see the values are much more clustered in the logarithm format than with the actual format. You can see it's here from about -3 till about 3, where this is about -4 till about, more than 4, almost to 6. And so you can see just what I was talking about in terms of the variance. By using the log, the variance are much smaller. The range, if you want to call it, the standard distribution, standard deviation, whatever you want to call it, that measure of skewness, are much less than when we do it in the actual value. So that's why our visualization is much more intense using the log than when we don't use it. So as I said, that just shows you. You can see the more on I statistics is a bit smaller because of this outlier. So here again, you can see the significant outliers. What's that value there? So that's a major. You see, you wouldn't necessarily look at that item or that location as an outlier when you looked at it in actual format, in its true format. But when we have it in log, you can see it's a massive outlier. So let's have a look and see where's that value location. Let's have a look. It sits there, I think. Yeah, it's that value there. So that's a harbor. This is ndvi. So this is most probably we don't know what exactly. So if we open the table, let's see if we can find it. No, we don't know where that value sits. We don't know where that value, well, we know where the value is, but we don't know what the ndvi value of it is. So we'll have to go and investigate it a bit further. But point being is, outliers are much more evident when it comes to using it in log form than otherwise. So let's click on that one there. Where's that one? There it sits there. Again, you wouldn't necessarily say it's an outlier if you look at the actual values, but when you look at in log format, you can see it's an outlier. Let's do that one. You see these 3 locations are basically, okay, so those one, that location, and that location are basically, come on, you have to be so absolutely under. So these 2 are roughly the same location. This one, where's that one? Come on. Sorry. Hey, I've got the, there we go. Where's that one? Can't see him. Don't know where that one is. Okay, so that's also there. Yeah, that's also there. So that one, that location, and this location is basically on the same level. So these 4 outliers are basically located there and here, next to the river. So yeah, so that's just practically showing you the difference between using the values in its natural format, in its actual format, and versus using the variable in its logarithm format. And as I said, it basically decreases the variance or the standard deviation, whatever measure of skewness you want to use, the range, etc. So it condenses the data much more and stuff. So as I said, it's visually it makes a huge difference in the data and stuff, and we can see the finer details much more intense. So that just shows you, and I would again strongly suggest or recommend that you use it. Now, in terms of a regression, let's quickly have a look and see whether it does make an. And I'm going to go straight to, let's do the rook in this case. Let's go spatial lag, and let's run it to see whether now. I hope this thing doesn't crash, as in the previous one. See whether it actually does something. But as I said, I'm just worried that it's going to crash. So just stand by. If it crashes, then that's the end of this video as well. So while that's happening, let's not play around. You see, I've got the file open now in QGIS, and I've got the file open in GeoDA. So I don't want to work in both files at the same time. So just be careful. That's why I always say is when I work with the file in GeoDA, I'll save it as a GeoDA file and only work with that GeoDA file in GeoDA, except when I do these sort of mathematical calculations. So that's still running. Just another thing while this is working, one of the other benefits, and I haven't spoken to that about operating in GeoDA, is we can create spatial lag variables. We can create spatial lag variables. We can generate it. So that is what this calculator, the GeoDA calculator, is very good at. It calculates spatial lag variables based on the spatial weight matrices. That variable that's being used within this regression. And I haven't showed it yet, but that's one of the nice benefits of GeoDA as well. It can create those spatial lag variables based on the different weight matrices. So you can generate those time series or those variables, the data for those variables within GeoDA, which is quite good. And that also you can present visually, and it brings another dynamic to your analysis. So just bear that in mind. I don't want to interrupt this now. Oh, there we go, done. So let's quickly have a look. And I'm not going to do more on regression because as I said, it takes a long. You can see, oh, now the rain is not statistically significant. So that's interesting. Why would that be that? And we still have the same problem. So from a regression point of view, it hasn't really made much of a difference. But as I said, this is just very intuitive. I haven't done much. I don't want to spend too much time on regression in GeoDA because I'm concerned it will crash. Maybe just to show you, close, if you go to the table and you right click on the table and you say add calculator, okay, you'll see it can create the spatial lag variables. So we can say we want to create a spatial lag variable of, let's say, our log ndvi. That would be the result. The variable would be our log ndvi. So our log. So yeah, we first have to generate. Okay. So what we first have to do is just quickly minimize that. Oh, sorry. Let's close this quickly. Let's quickly do that. I just want to quickly close the table. Okay, now. So first what we have to do is create a new variable. Add a variable, and let's call that ndvi lag, lag 1. Let's call it just lag 1. The rest we're going to keep exactly the same. And there it sits. Okay. So what we're going to do now is going to go to calculator. We're going to say we're going to use the queen. Let's use the queen. The variable will be that. And then the variable that we're going to generate is this lag 1. You'll see the lag 1, this empty one that we're going to generate now. That one there. So that's the result, the variable, and it will be the queen times the ndvi. Okay. So we're going to create now a lag variable. Okay, we're going to create a lag variable of ndvi based on the queen matrix, weight matrix, and we're going to press apply, and there it sits. Okay, so let's quick. I've used the ndvi, and there it sits. Okay, so there is our. Let me just. It's really a bit annoying. There sits our lag weight matrix. Lag, spatial lag ndvi, log ndvi, spatial lag log ndvi. Let's have a look and see what that looks like. If we go to seamless again, let's go to natural breaks 8, and we're going to go to our spatially lagged ndvi, and we're going to press OK, and there that really is. We can compare the two. There's the log one. Let's say that it's the lag in it, and you can see it's almost 100%. Where's that outlier again? Come on. There we go. It's again that one there. You can see that one there. Anyway, there is the scatter plot between the log ndvi and the spatial lag ndvi based on the did we use the queen, I think, and we can do the rook and then see what the difference would be, etc., and we can play around with it. So as I said, that's another valuable. So we're just going to add variable. So let's call it again. Call it len ndvi lag 2. Log ndvi lag 2. Let's add it. And then we're going to go calculator. We're going to do, must be 2. And we're going to do the rook. Keep that the same. Apply. There it sits. Let's have a look and see. And there you can see the difference between the two. They're not hugely different. There is some differences, but it's not all of them. And that's why there's not a lot of difference between when we use them in the analysis between. So remember, this is what the 8 neighbors, and this is the 4 neighbors. So including that extra 4 neighbors doesn't really add much to it. Okay, so let's close that. Let's save. Okay. So yeah, so that was just a quick video tutorial that I wanted to do on the using of the lags, how to generate the lags of our variables, and some of and why I strongly support or recommend using the logs in our analysis, because of the big benefit if it condenses the variance, and therefore it brings out the minute differences much more than if you use it in actual values. So that's just my preference. It's up to you to decide, your discretion stuff. But anyway, just something quickly, something more playful, something I think, something to consider. So thanks a lot. I appreciate it. Yeah. So keep it up. We are well on our way on our journey in remote sensing, and what a journey it has proven to be so far. A journey that has taken me and the channel to very interesting places. So yeah, thanks for your comments and your support. I really appreciate it. Please remember to like, subscribe, smash those buttons. That's part of the journey. So please do me a favor, or not a favor, please, I need your support. I need your support. With that said, I'll see you soon. Next video is on its way, and I'll see you on the other side.